Good morning, everyone. Thank you for participating in the late breaking news session today. Let me introduce our first speaker. I'm Jun Kawaguchi from JAXA, who has coordinated this late breaking news session today. We have a speaker, Hiroshi Sasaki, who joined at the NASA, National Space Development Agency in 1987, and he worked first for the transportation development. And currently, he has been doing that HTV project for 14 years, and he is in charge of system integration and mission management of HTV project. He is currently the function manager over at HTV project. Let me introduce Hiroshi Sasaki.
Good morning, everyone. My name is Hiroshi Sasaki, function manager of the HTV project team, JAXA. I'm glad to present and report the HTV status to at the IAC. Last time I presented the HTV 10 years ago, I could just a concept of the HTV, and also since there are no hardware even on the ground, so this time I can explain the real hardware on orbit. Okay, and maybe someone don't know the HTV details. So first, I'd like to explain what is HTV, and then I'd like to show the video of the HTV launch. First, I'd like to explain the HTV objectives. There are three objectives. One is supplying the 6 tons of cargo to the ISS. This is Japanese obligation of the ISS program. Second one is utilize H2A and H2B launch vehicles. We need to support HTV. JAXA launch vehicles development activities. The last one is to demonstrate the key technology such as automatic rendezvous and man safety design. And this page shows key technology of the HTV. HTV is designed based on the Japanese existing program, such as launch vehicles, satellite, and space station. There are 5 key technologies. First one is most important, automatic rendezvous system under the man safety regulations. JAXA have an Orihime Hikoboshi, the demonstrator of the rendezvous, but HTV conducts the automatic rendezvous under the man safety regulation of the ISS. And second, multiple redundancy system of the ammunition and propulsion system. HTV has not only double strings, but also the triple strings or more. It is the first time to develop such multiple redundancy system. The third one is export cargo handling system. HTV has a unique mechanical system in the ISS world. The fourth, man-designed pressure sections. HTV has air from the ground to the station, and the crew can enter easily to the HTV. And the last one is large size and heavy vehicles. It is most it is the biggest and the heaviest vehicle launched from the station. HTV is 10 meter long, 4.4 meter diameter, and weighs 16.5 tons, almost same as the sightseeing bus, like this. And next are HTV-1 missions. HTV-1 has three important missions. First one is a demonstration of the HTV capability, automatic rendezvous and capture operations and cargo transfer operations and re-entry. And most important is safety critical functions such as abort capabilities. And also the important items uploads pressurized and unpressurized cargoes. HTV-1 has 4.5 metric ton cargoes, 3.6 metric tons of the pressurized cargo, and 0.9 metric ton of the unpressurized cargo. As for the unpressurized cargo, there are two payloads, SMILES of JAXA and HREP of NASA. And the last one is HTV need to dispose lots of ISS waste cargoes. Now the crew loading the ISS waste cargoes. And the schedules are here. HTV was launched September 11th and burst to the station September 18th. And now on orbit. And HTV will depart from the station, currently scheduled on October 1st. This is a video.
Main engine start. SRB へ点火。リフト。新しい時代へ。宇宙ステーション航空機 HTV 融通実証機を搭載した H2B ロケット試験が午前2時1分46秒種子島宇宙センターから打ち上げられました。ただいまロケットは完成飛行をしています。
Separations H2B has a full SLBA. This is separation of the fairing. Was also developed for the HTB. And this is a first stage separation. And this is a HTB separation.
HTV 分離。
HTV separation.
This is a view from the ISS. This is a first look from the station. HTV was at the 5 kilometer after the station, and then HTV go down to the 500 meter under the stations and go up to the stations. And crew monitor the HTV locations from the camera view, and also using overlay. The crew prepared the SSRMS, and this is a SSRMS camera view. And HTV moved slowly, about 1 centimeter per second to the station. And finally, crews send a free drift, inhibit the thruster firing, and then capture the HTV by SSRMS. And after checking the connections surfaces, and then crew bus the HTV to the stations. And busing completed 4 a.m. on September 18th. And then crew connect to the power line, also the air line to open the hatch. And then they open the hatch and then enter. And the crew puts the Hinoma Japanese flag to the HTV. And this is a conversation between the flight director and the crew. And three crew, ISS crew supported the HTV rendezvous, and Nicole, Bob, and Frank. And this crew from the NASA, ESA, and CSA. So the successful capture and rendezvous operations is a result of the good international partnership of the ISS BD. After the berthing, the next critical operation was exposed pallet handling from the HTV to the Kibo modules. SSRMS removed the exposed pallet from the HTV and hand over to the GEM-RMS. And then GEM-RMS attached the exposed pallet to the Kibo exposed facility. And then GEM-RMS attached the two payloads to the exposed exposed facility. And then GEM-RMS hand over to the SSRMS, and SSRMS reinstall the exposed pallet to the HTV. Okay. This is current status of the HTV. Next, I'd like to explain briefly of the HTV operation overview. HTV has 7 operation phase. Pre-launch phase, and the launch phase, and the rendezvous phase, integrated operation phase, and attached phase. Now, HTV is attached phase. And then departure phase and re-entry phase. Pre-launch phase, in Tanegashima, we have a big spacecraft fairing assembling, and HTV module checkout, cargo loading, and assembly, final checkout, and propellant filling, and fairing and encapsulations are conducted on the same building. And then HTV covered by fairing moved to the launch pad and launch. HTV-1 was arrived to Tanegashima in April, so we took the 5 months for the preparations. Next, launch phase, H2B separates the HTV about 15 minutes after launch. This is the first launch. This was the first launch of the H2B, but there are no launch windows. But H2B inserted HTV at a nominal orbit, and also there is no launch delay. Very perfect launch, we think. Next, rendezvous phase. After the separations, we have 2 phasing adjusting orbit, and then arrive to the stations. And before the arriving stations, we need to conduct the abort demonstration to confirm the safety critical functions. Just after the 1 day after the launch. And then we evaluate the all data and report it to the ISS program, and ISS program accepted the result. And before the approaching the go decision from the International Mission Management Team. this chaired by NASA, but also JAXA, ESA, CSA, and Russia attending. And then we come to the HTV, come to the station, near the stations, and HTV has a direct, established a direct communication link with ISS and start the relative GPS navigation and stop near the station. We call the AI point, 5 kilometers after the station. Then the HTV evaluated the relative rendezvous GPS navigation, then started the integration of final approach, and then come to the 5 meters below the station. And then use the rendezvous sensor for the final approach. And then the HTV go up from 5 meters to a capture point. And during the Alpha approach, we also crew send a command to confirm the connectivity between the ISS and the HTV. And right figure is a crew device for the HTV control. There are lots of commands, hold, retreat, or abort. And left side, SSRMS control crew devices. They use this device for the capture. And finally, as I mentioned, September 18th, 4:01 a.m., crew complete the capture. This is a capture concept. This is a new rendezvous and docking operations concept. And HTV stopped the predefined locations, almost 1 meter cubic. And SSRMS captured this FRGF. And this is a new FRGF because for the safety purposes, HTV has a separation plane between the FRGF and the HTV, taking account of some miscapture operations. This is new hardware. This is a benefit and the challenge of the capture concept. Since we don't use docking, HTV can carry the large size cargoes and also passively safe approach, and also the final zero velocity almost at zero. Very safe approach. But we have a challenge, a very difficult operations of synchronized operation of the between IS crew and ground flight control team, both JAXA and NASA. But HTV can deliver the big size such as LAC, impressurized cargoes, and also very big unpressurized external cargoes. This is a view from the crew monitor the HTV location using the overlay and checked the locations. And if when HTV FRGF come these areas, then crew starts the capture. Before the capture, crew send a free drift command to inhibit the thruster firing. Okay, next current status. So after the rendezvous and the capture and the brassing operations, we started the cargo transfer, and now 72% internal cargo transfer was completed. And this week, we hope all cargo transfer will be completed. And external payload transfer, I showed the operation at video, and all cargoes was already transferred to the exposed facilities, like this. And next step, now we are loading the trash, maybe until October 29th. And then we close the hatch, October 30th. And the HTV will depart from the stations October 31st. And then we will conduct the re-entry, currently scheduled on November 2nd. And this is HTV future. We launched the HTV1 2009 September. Then we will launch 6 HTVs per year to meet the Japanese obligation of this program. And then we have not decided yet, but we are now starting the next step. That's all on my presentation. Thank you.
Thank you very much. Time for the questions and the comments. And do you have any other comments? We have 8 minutes to start on the plenary session. Yes.
Yeah, still under studying, but one option is accommodate some capsule of the HTV at the logistic carrier sections.
Any more questions? We have several minutes to the plenary session. Will you show that some ideas about how many flights you are scheduling, and when is the next flight?
Okay. Currently, HTV2 launch was scheduled in January 2011, and after that, we plan to launch one flight per year. This will be decided not only JAXA but also NASA, taking account of the cargo allocations. And now we fix HTV2 launch schedules, and then now coordinating the HTV3 launch schedules.